Welcome to Benefits of Constructible Models for Structural Engineers. I'm your host, Christine Plemons, the Marketing Manager for Trimble Structure Division, working with our Tekla Software Solutions. I'll be joined today by Amy Northcutt, the Application Specialist for our Engineering segment. Just a couple of things before we get started. You've joined today's call in listen-only mode. If you need to communicate with us, please use your control panel. You can type any questions that you may have during the webinar in the chat box. So I will let Amy give you guys an introduction. So with that, let me pass it over to you, Amy.
Thanks, Christine. So as she mentioned, my name is Amy Northcutt. I'm the Engineering Application Specialist working with Tekla Structures here at Trimble Solutions. And we're going to be talking today about the benefits of constructible models for structural engineers. First, let's just take a look at the agenda so you know where we're headed. Start with a little introduction, talk a little bit about constructability and what that means. I'll show you some examples of constructible models and constructible projects, some everyday use cases for constructability, the time required that it might take, and some of the benefits to using constructible models and creating constructible models. Before we get started, I'll let you know a little bit about me. As I mentioned, I'm an application specialist. I've got a bachelor's and master's in architectural engineering from Kansas State University. I am a structural engineer licensed in the state of California, and with both that, the structural engineering work, I've also done some rebar detailing all within Tekla Structures. So overall, why would you want to use Tekla Structures? Overall, our clients report being able to create a better quality product, enhancing their scope of work, compressing construction schedules, improve downstream collaboration, and reduce design time, all of which we'll cover throughout the presentation. So first of all, what is a constructible model? And I think first we have to say, okay, what actually is constructability or buildability? So constructability is a project management technique to review construction processes from start to finish during the pre-construction phase. It's to identify obstacles before a project is actually built to reduce or prevent errors, delays, and cost overruns. And I really think the most important part of that is to identify obstacles before a project is actually built. So the whole idea behind a constructible model is that it's built virtually in the computer world before it's built in the real physical world out on site. So here you can see we've got a picture of a conceptual model. But as I click here, you can see that more bits of detail are being added. So as we get our plates for our steel connections, our bolts, our welds, our embeds for the interface between the concrete and the steel, and the reinforcing all in the model, this then becomes a constructible model. It includes weights and center of gravity, surface areas, and surface treatments. You're able to check for clashes and make sure that the bolts will be able to be installed. If it fits in the model, the whole idea is that it will fit on site. This is a great example, one of my personal favorites, showing a Tekla Structures model, obviously a complicated steel joint, and then showing that same joint in the exact same space and configuration in the real world as it's been erected. So who's already creating constructible models and what are they looking like? Here's a few examples of some complex rebar. It's easy to see with the complexity here why it makes sense to model every nut, bolt, and every bar. They truly, over here on the left-hand image, they truly needed to model every single piece just to make sure that it would all fit inside that concrete. Here's another example of some complex bridge rebar and some complex steel connections. On the steel side, the connections here would obviously be difficult to digest and communicate only through 2D. And these sorts of steel connections are always modeled in 3D. It's usually just a question of at what stage in the project and who does that modeling. So here's some more specific examples. This is Leadenhall Tower, designed by Arup. This Tekla model has about 9,000 members as shown. Traditionally, the structural engineer wouldn't be responsible for the connection detailing, but on this project, the structural scope was to develop near fabrication level modeling of all mega frame nodes and architectural based connections. Here's an example from Bechtel and CMC. This is an LNG tank. This is in Corpus Christi, and the Tekla Structures model was used for rebar estimating, detailing, and coordination. CMC modeled piping, formwork ties, PT cables and anchors, and rebar and embeds. Modeling to this level of detail saved them time and mitigated risks by detailing the rebar at the same time as they were coordinating with the other trades. So they were able to identify the problems and solve them real time. This is the Hudson Yards project by Thornton Tomasetti. I'm sure you've all heard a lot about this at this point. It's a pretty prestigious project going on. This is modeled in Tekla Structures. There's about 72,000 tons of steel here. According to Thornton Tomasetti, this project wouldn't have been possible without this level of detail. Thornton Tomasetti's construction services team worked with their design team to get the detailing started before the 100% CDs were issued. This allowed them to get fabrication and procurement underway, and they were able to gain a minimum savings of up to 6 months up front by doing this. So it's easy to see why some of those large complex projects would need to be modeled to a higher level of detail. It's easy to see why a constructible model makes sense for those. Sometimes the geometry simply requires it. But even more standard, typical projects can have these sorts of constructability issues. And so I've provided a couple examples here of just what those might be on more simple projects. So over on the left-hand side, we've got a footing schedule, and over on the right-hand side, we've got a base plate detail. Our footing size and depth is communicated through the footing schedule, fairly standard practice for our structural engineers, and the anchor bolt design is communicated in a base plate detail, possibly a typical detail. It depends. So the concrete contractor sees this, and they go about their job excavating for a 2-foot deep footing. The steel detailer sees the detail, and they start detailing their anchor bolts with a 24-inch embedment. No one realizes that this is an issue until the anchor bolts get out to site. All of this could have been prevented if an engineer had built a constructible model. If they modeled those anchor bolts with 24-inch embedment and their 2-foot deep footing, they would have very quickly seen that the anchor bolts stick through the bottom of the concrete and don't actually fit. Here's another example. This is a fairly typical foundation rebar section. The grade beam reinforcement is specified in a typical detail. So they've got 4 number 11s in the bottom of this pad, or in the bottom of this strip footing. That's all fine, but what they don't realize is that those number 11s have an 87-inch development length. This means that when they're modeled, they go all the way clear through a pad footing, outlined lightly here. Let's see if I can pull my mouse over so I can show that. They go clear through the pad footing and through the pad footing rebar. Now, if the engineer had modeled this, they would have clearly seen that either I need to dogleg my bottom bars to go through that pad footing, or I need to pull the pad footing bars up on top of the grade beam bars, or perhaps one of those beams or the pad footing needs to be deepened. It doesn't really matter what the solution is. It matters that we've seen that there's going to be a problem when this gets out to site. Here's a couple other examples of engineers who clearly weren't producing constructible models. I'm sure that this isn't what they intended with their 2D drawings. As an industry, are these really the types of things we want to be producing? For this one, I can literally hear someone now saying, oh, it's just a gusset plate. How big can it possibly be? Pretty big, as it turns out. Shouldn't we hold ourselves to a higher standard than this as structural engineers? Issues just like this gusset plate are fairly common, especially when engineers aren't going and detailing out their bracing connections prior to detailing and fabrication. And so we've moved from the drafting board producing 2D documents to computer-aided drafting or CAD software, but still producing 2D documents. During that transition, there was definitely argument as to whether or not we're actually improving the product or the deliverable. And now we've moved on to creating 3D models, or BIM models, building information models, but still producing 2D documents. So where are the future of drawings? Do we really need 2D drawings now? Some of us say that they need them to be able to build out on site, and perhaps that's true in many cases. But we've already seen many cases where contractors are taking tablets and computer hardware out on site for construction. So it's possible that in the future this will be the way that we evolve. In our traditional approach, through each stage of the project, the information is dumbed down and communicated on a set of 2D drawings for the next person to pick up and reinterpret throughout this process. So throughout the entire life cycle of the project, we're losing information each time. Every time we make a step from one stakeholder to the next, they have to open up a set of drawings and reinterpret them. How does that make sense when we can do so much better? Using a model-based deliverable, we can pass the model on to the next stakeholder and simply add information each time. No need to dumb down our work for someone else to reinterpret each time. So as we're going forward, with the level of information available in the 3D model, what's to stop us from using this information, this better, more rich information, to build from? Here at Tekla, we're of the opinion that drawings aren't here to stay. In 50 years, will we still be producing 2D paper drawings? I sure hope not. Already we're seeing models being used out on site for clarity on top of the 2D drawings. Our current practice is to create design documentation as structural engineers. Our main goal for our project is to convey design intent through 2D drawings. This may be through a few floor plans that have been created based on a model, but largely we're using typical details and column and beam footing schedules. And there's generally little to no thought about constructability. That's usually means and methods, we say. And that's what we're paid to do as structural engineers, right? So why would we do anything more when our schedules are already tight and our budgets are already tighter? We all agree that we don't want our projects to end up like any of those that we just saw. So what if adding the detail didn't take more time? What if working this way could be even faster and more efficient than the way you're working now? Let me show you what I mean. Here's an example of a Tekla Structures model where I've got some basic steel framing modeled in. I've got steel column, steel brace, and steel beam here. And I'm going to use a system component. This is our wraparound gusset from the Applications and Components catalog in order to model in this connection geometry. So as you can see, with just 3 clicks there, I was able to get that connection modeled in very quickly. And this includes all of the weld information, site bolts, field bolts, all the information required to build and construct this connection. Now, within our system component dialog, you can see there's many different options here. So I can come in and change the plate size, the bolt spacing, the number of bolts, the weld size, so on and so forth. And then I can apply that same connection in different areas of the model where it applies, and use those settings that I've created here over and over again so that I generate the same connection in multiple places throughout my model. I can go over here to the right side and put that in just one more time. And you can see it's very fast to get all that information modeled in. Now, one of the benefits to using these components is that they are parametric. And so right now I have a W16 beam, but I want to change that. This is for whatever reason on this project, that beam needs to get upsized, and I'm doing it to a much larger extent, or to a much larger beam here so that you can really see the difference. So once I redraw this view, you could see, or hopefully you saw as I changed that beam, all of my connections regenerated, and the parameters that I specified within this connection updated automatically. So the spacing between my bolts and my plates there are maintained from the bottom of my flange as I set within that system component. So that's part of the benefit of using these parametric connections, is that they're going to update automatically. And that can apply for the concrete side as well. So here you can see I can model in some rebar using system components from our Applications and Components catalog again. These system components are intelligent and parametric, just like our steel connections. And so with these, within the system component, I can specify the size of the rebar, the cover of the rebar, the spacing, so on and so forth. And then when my concrete size updates, those parameters will be maintained, but the rebar can update automatically. So I've obviously gone through based on the various element types and added pad footing rebar, strip footing rebar, and here's some column pier rebar. And I can even come in and model in slab bars. So with just a couple clicks, I'm able to get both my top and bottom mats in with the appropriate amount of cover. And then I can even scroll down and grab the edge and reinforcement tool. So while I may not have all my laps in this model, I might not have this, I wouldn't consider this fully detailed rebar. As an engineer, I can at least understand that the bars and then the quantity and size and spacing of these bars will fit inside the concrete that I've specified. So it shouldn't take longer. It should actually be faster than the alternative. And within Tekla Structures, your drawings can be extracted without the need for going in and modeling this tedious this 2D tedious line work as you're going through. Because you've got all this information in the 3D model, it's easy to convert that to 2D drawings and 2D details that are, again, parametric and can update automatically. So I've just created an elevation of this brace frame, similar to the one we were looking at before. And I may need to come in and shift a few of these marks, and I could add some additional dimensions if that's of interest. But in general, a lot of this is automatically created for me. I can come in and create a detail of this connection just by adding that detail view and giving that a location on my drawing here down below. And with the various view settings that I've used, I can have different settings for the different types of views. So an elevation view is going to have different things called out and dimensioned and annotated than an elevation view. So here I'm just loading those detail view settings. And when I zoom in, you can see I've got a number of additional things called out here on this detail than what I had in that elevation view. So here I've got the annotations for that connection in and out of the plane, and I'm just going to delete those because those aren't necessary for this particular detail. And I can shift some things around as needed, but I've got my plates all called out, my angles for my connection all called out, my braces all called out, and really I can count on the fact that this detail is going to be up to date no matter what happens to the geometry of this particular area, or if I come in perhaps and change the size of this beam. So at the moment it's a W24, and I'm going to downsize this beam to a W16. I'm just pulling that new profile from my catalog, updating my connection, my geometry, and then my connection's updating automatically here. And then when I reopen that drawing, we'll be able to see that just like in the model, this drawing will have updated automatically based on the new geometry that I put into the model. So if I zoom in here, you can see that my wide flange callout got updated, and even my dimension here was updated, and it's clouded to show me that that's been updated in my model since I last opened the drawing. Now, if you're interested in working downstream and opening up an additional revenue stream, that doesn't have to be that time consuming either, especially when you're already modeling accurately and to a high level of detail. So let's just quickly walk through what that can look like. Here in my model, I've already produced my construction documents, for instance, and I'm going through and I'm numbering my beams and my columns, and I'm taking a look to make sure that I've got independent design group marks, so that would be for my construction documents, from my actual part marks, which will be used for my fabrication shop drawings. So I can come through and load settings for my column shop drawings and just go through and say create assembly drawings, and we can take a look at what a couple of those look like. As I browse to my assembly drawings in my drawing list, you can see I've got a number of column drawings listed here. And if I open one of these up, you can see that all of this information is automatically generated from the Tekla Structures model. So because I've got all of my connection information, because I've got that high level of detail, I'm able to take advantage of that and take that one step further down to fabrication. So if this is of interest, it doesn't have to be that time consuming. We've got an automatically generated bill of materials. You can see it's giving a count. There's only one column just like this one, and it's even showing you the location up in the top left corner there. Now we can do the same thing for our beams and braces, and I'll show you that. And as I'm doing that, I do want to clarify one thing. I'm not suggesting that all engineers can actually all of a sudden become detailers. I think it's really clear that all of our detailing partners and coworkers have a very specific knowledge base and skill set, and we absolutely need to lean on them just as they lean on us for the structural engineering. The first step, however, would be building partnerships with detailing partners that we know and we trust, and then from there, if you are interested in creating another construction, if you're interested in creating another revenue stream, I think it's important to remember that you need to have the appropriate knowledge and skill set inside your office in order to do that successfully. So I've been going through just showing you what some of these beam drawings can look like. Obviously, all of these dimensions of our bolt holes and connection information is generated automatically on these drawings. You can see I've got two identical B52 beams that are shown here, and I can do this for my braces as well. So all I'm doing is going back to the master drawing catalog, and in this case what I'd like to do is create some single part drawings. So I'm just going to use one of our wizards that are set up in our master drawing catalog to create the single part drawings for all of those individual plates in the model. Now I can browse to my drawing catalog and take a look at just those single part drawings, and I'll just browse through just a few here so that you can get the idea of what can be created automatically based on the geometry inside the Tekla Structures model. So you can see I've got lots of dimensions and lots of angles on here, but all of this would be required in order to build this or to fabricate this plate. And it's possible that some of that just needs to be shifted around, but you can see all the dimensions required are already there. So there's not a need to go through and tediously generate this 2D line work. It's already created for you with your constructible model. Okay, so one of the questions I hear a lot from our potential clients is, what if I'm required to deliver a Revit file? So your architect is working in Revit and they say we need a BIM model. In some cases they may say that we need a Revit model, but it's important to understand that Revit doesn't necessarily equal BIM. Revit isn't BIM, it's a BIM solution. So the important question to ask is the architect using your Revit model in their drawings? If they aren't using your model in their drawings, then the best way to communicate your design to them in terms of a model is probably through an IFC file. With the IFC file, you're able to include any attributes that are relevant, so part sizes, callouts that you've added, any information that you want to convey to them that's in your Tekla Structures model, you can attach to your IFC members, and it will be associated with those when they open that IFC file up inside of Revit. Now, if they are using your 3D model inside of their Revit drawings, then we do have a solution for that. We have an Export to Autodesk Revit extension that's available on the Tekla Structures warehouse. What this will allow you to do is map your Tekla Structures members to various Revit families and include them on the appropriate levels. So this is an option for you. Tekla Structures is focused on open BIM, so we like to work with everybody. And if you're listening on the call and you're thinking, well, what if I don't want to work downstream? That's okay. There are plenty of benefits that you can get from using a constructible model or creating a constructible model without having to open up that construction services team or without having to work downstream. So the first benefit is really for yourself. You have a truly constructible model and design. As an engineer myself, this was extremely important to me. I had confidence in the design that I was that I was creating, and I knew that that would be able to be built once it got to the site. Coordinating with actual connection geometry. As a profession, I think engineers catch a lot of flack from some of our construction counterparts because a lot of this may seem like it's outside of our scope. The connection geometry might not be in our scope, and so that's not something that we design. But as a profession, isn't it time that we remedy this? Where there's a complex connection and there's a possibility that this might not fit, wouldn't it be worth our time to save us a few RFIs down the line to actually model that in to see if the proposal will fit? You're able to clash check at a high level of detail. So you actually know exactly where that gusset plate is and if the pipe will be able to fit in around it or not. Your parametric 2D drawings. So as I was showing in the video just moments ago, your drawings are going to update automatically when your model updates. So you don't have to worry about if you've only called out that one beam on one sheet or if that dimension is shown on 2 sheets, because even if it is shown on 2 sheets, it will update in both of those places. You can pass out useful models to the detailer. So even if you don't want to do that detailing yourself, you can possibly save time on the construction schedule by handing that model to a detailer and allowing them to get a leg up. And lastly, but certainly not least, there's the potential for fewer RFIs. And I have a few examples to that point that I'd like to share with you. The first of which is the Port Canaveral Welcome Center done by Thornton Tomasetti. In this model, Thornton Tomasetti worked with MEP to resolve clashes in the model prior to fabrication. This model was an LOD 350 model and included all large connection material as well as an accurate superstructure. This project was completed with less than 10 RFIs total. This is Quantico Hanger, another Thornton Tomasetti project. Their construction engineering services team modeled all the connections for 760 tons of steel, and this project was completed with only 1 RFI. This is another project from Fluor. The engineer created this model in Tekla Structures, and then they passed that model to the detailer. Doing this allowed their detailing cycle for the detailer to be reduced from 6 weeks, which is what they traditionally allow, to 2 weeks for this project. And using a model-based review process of the Tekla Structures model, that time frame was reduced from 2 weeks down to 3 days. Their last project that they issued with just a cover sheet and a Tekla Structures model, no additional 2D drawings, and they only received 8 RFIs on that project total. And if you are interested in working downstream, then the advantages get even bigger as you go further downstream. So first, as we mentioned, there's a reduced design time. With fast modeling capabilities and drawing production and in-model shop drawing review, you're able to compress both your design time and your review time. You're delivering a better quality product. So an accurate model and drawings and material takeoffs, those are huge to your project and add value. Your model is constructible, so you're likely receiving fewer RFIs, and there is a possibility for an enhanced scope of work and an additional revenue stream by doing steel and concrete detailing or by simply delivering connected, accurate models. You're able to improve that downstream collaboration. So share information with your project teams. Share better, more quality information, higher level of detail information with your project teams so that they can coordinate appropriately and so that they can put out early mill orders and get CNC data out of your Tekla Structures model. And then there's the potential for you to be able to help compress the construction schedule. If the engineer's model can be used downstream, then the detailing can begin earlier. So modeling major connections is a great place to start. Adding a construction services team like Thornton Tomasetti or Walter P. Moore are doing can add a revenue stream, and this can be a huge benefit overall to your project. Some of these are benefits just for you as the structural engineer, but many of the benefits are for the entire project. And that being said, there is a benefit to consistently being involved in successful projects because people will want to do business with you. They want you on their team if you're consistently involved in successful projects. Okay, well, if you have any questions, please email them to tekla.info.us@trimble.com. Thank you very much for your time. I appreciate it.
Thank you, Amy, and thanks everybody for attending today's call. If you'd like to view or share a copy of this presentation later, please visit our website at the URL there to see a copy of today's webinar. Thanks, guys.